Hi guys, welcome back to lesson 21.3, where we are going to be talking about exponential graphs and their asymptotes. This will be a note sheet that's posted on Google Classroom. You will want a pen or a pencil and also your calculator or Desmos pulled up. We are going to be determining when an exponential function is increasing or decreasing, and we are going to describe end behavior of exponential functions and identify asymptotes of exponential functions. Excuse me. So first up here, a function is said to increase if the y values increase as the x values increase. Okay, makes sense. A function is said to decrease if the y values decrease as the x values decrease. So if you see here, as we move from left to right, meaning as our x values increase, our y values increase. So this is an example of an increasing function. Same thing here. We're increasing. As we move from left to right, it's going up. Okay. Then over here, as we move from left to right, it's going down. Okay, so this is an example of a decreasing function. Same thing here, left to right, we're going down. Okay, so that's what we're looking at. Now it says to also notice how the graphs start to flatten out. So in all of those that I just drew, it started to flatten out at some point. So here it flattens out, here it flattens out, here, and all of those happen to be the y-axis. But that's actually called a horizontal asymptote. And all of these have a horizontal asymptote at y equals 0, which is the y-axis. And so a horizontal asymptote is a horizontal line, y equals a number, so in this case 0, that the graph approaches a y value but does not ever cross. So in all of these, your graph is getting closer and closer and closer to 0, but it's never actually touching or crossing it. So it may even look like in some of them that they are touching or crossing, but it's not. It's just getting increasingly closer to that y equals 0 line. Okay, so it says here for the parent function, which we know the parent function is like the most basic function, right? Y equals a times b to the x, which we saw in our video yesterday. The horizontal asymptote will be y equals 0. So that's why in each of these, there aren't any transformations. So that is why it's approaching, or y is 0. That's where the asymptote is. Okay. This is going to be extremely important for end behavior, which is what we're going to talk about next. Okay. So basically, before we used to only see end behavior that approached negative infinity or positive infinity. But now that we have horizontal asymptotes, your end behavior can also approach a number. So in this case, it can also approach 0. So remember, your end behavior describes what is happening to the y values on the tail ends of the graph. And now the y values can go to negative infinity or positive infinity still, but also 0. And remember, this is the notation, and it's always set up that way. So I've actually went ahead and included those down below. Okay, so those last 4 graphs we looked at, we're going to go ahead and identify the end behavior. And remember, as x approaches negative infinity, that's to the left. As x approaches positive infinity, that's to the right. So this is what we want to figure out. So as we move to the left on our graph, what is this approaching? And it is approaching that asymptote at y equals 0. So we would say y is approaching 0. Okay. Then as we move to the right, oops, let's put that right. That's going to be, as we move to the right, what's happening to your graph? Well, that's going up towards positive infinity. So that's what we're going to say, to positive infinity. Okay, let's try another one. So as x approaches negative infinity, so as we move to the left, What's happening? Well, this is pointing downward. So we would say y approaches negative infinity. And then as we move to the right, towards positive infinity, what's happening? Well, your graph is approaching that asymptote, so 0. Okay, let's try one more as we move to the left. Or as x approaches negative infinity, what's happening here? Well, it's going up towards positive infinity. And then as we move to the right towards positive infinity, what's happening to your graph? Well, it's approaching that asymptote at y equals 0. Okay, so I want you guys to go ahead and try to fill in this last one here. So hopefully you got, as you move to the left towards negative infinity, it is approaching the asymptote at 0. And as you move towards the right, positive infinity, the y is going down towards negative infinity. Okay, so that's the big thing now, is that we can have an end behavior that approaches negative infinity, positive infinity, or 0 because the horizontal asymptote is at y equals 0. Maybe you want to jot yourself a little note. HA, I like to call it, horizontal asymptote, is at y equals 0. And that's why we can now have an end behavior at 0. Excuse me. All right, so then the last thing we are going to talk about is just kind of putting that all together and looking at all of those pieces of information. But actually, before we do that, we want to talk about one more key feature, which is the y-intercept. So remember, the y-intercept is located where the graph crosses the y-axis. And again, for our parent function here of y equals a times b to the x, the y-intercept is going to be that a, okay? So it's just that initial term. Remember yesterday we talked about the b value being the growth or decay. So that was your exponential growth or decay. Well, the a value is your y-intercept, or your initial, your starting point. So that's important to know. Okay, y-intercept. So all we have to do in these, identify the y-intercept. So that's your a value. So we would just say that the y-intercept, and remember that's a point, it's where your graph crosses through the y-axis. So we would say that as 0, 3. Okay, same thing here. Your y-intercept is going to be at 0, negative 1/3. And then this last one, y-intercept is at 0, negative 2. And that's it. It's just your a value, your initial value. Cool. So now, like I was saying, let's put it all together. And what you guys can do is when you're given a function like this one here, you can either, plug it into your graphing calculator or plug it into Desmos. And either way, you'll be able to kind of get an idea of what it looks like. But then you're just going to identify a few pieces of information. So first of all, is it increasing or decreasing? So as we moved left to right, is it going up or down? Well, it's going down. So we're going to say this one is decreasing. Where is your horizontal asymptote? Well, again, we haven't moved it up or down or left or right. So we're going to say that that is at y equals 0. Your x-intercept for all of these if you have a horizontal asymptote at y equals 0, meaning the x-axis there, you are not going to have an x-intercept. So you're going to say none. Okay. Then your y-intercept, you can see where it crosses the y-axis here, and remember you can find that right here. So that's at 0, -3. And then your end behavior is just like we were doing. So as we move to the left, what's happening? It's approaching that asymptote. So it's approaching 0. And as we move to the right, what's happening? Well, it's going downward, so -infinity. Okay, so we're putting all of those key pieces of information together. Okay, let's try another. So you have y equals -6 times 1/4 to the x. And you have to figure out if it's increasing or decreasing. So as we move from the left, as we move from the left to the right, let's see what's happening here. It is going up, so it's increasing. Then where is your horizontal asymptote? Again, it's at that y equals 0, nothing changed there, which again means we do not have an x-intercept. Where's your y-intercept? It is at -6, so 0, -6. And then your end behavior, as we move to the left, it's going down towards -infinity. As we move to the right, it's going towards your asymptote at 0. Okay, let's try one more together, and then you guys will do the last one on your own. So again, you can just graph this in your calculator or Desmos when you see it. You have y equals 1/2 times 1/4 to the x. And is it increasing or decreasing? So as we go from the left to the right, that is decreasing. Horizontal asymptote is still at y equals 0, which means we still have none for the x-intercept. And your y-intercept is going to be right there, or right here at 0, 1/2. And then your end behavior, as we move to the left, what's happening here? Going up towards +infinity. And as we move to the right, what's happening here? Approaching our asymptote at 0. Okay. Also notice on these three guys, from what we did in class the other day, when we look at that 1/4, we know that that's a number between 0 and 1, so that should be decreasing, right? We talked about that. So looking at it should be decay, right? So that would mean that it's decreasing. That's what we talked about in yesterday's video and in class, okay? But then this one, why isn't this decreasing or decay? It's because of the negative out front. So that kind of like negates it and makes it increasing. Okay, so think about that as well. And then same thing here. Normally a 2 would be growth, right? But because it has the negative out front, that's what makes it decreasing. Okay, or again, you can just look at your graph and notice, okay, as we move left to right, it's going down. Okay, so I want you guys to go ahead and try this last one, and then we will do some more practice with this in class, and I will leave an answer key to this last one. But if you have any questions, please bring them to class tomorrow. Have a good one. Bye-bye.